Have you ever wondered how a computer processes numbers? Like when you type 4 plus 5 into a calculator? The answer lies deep inside the CPU, where tiny switches called transistors work in harmony with electrical signals. But how does it all happen? In today's video, we'll break down how binary data, like 0100 for 4 and 0101 for 5, gets converted into electrical pulses that control transistors in your CPU. Let's get started. First, let's talk about the binary data. When you type 4 plus 5, the numbers are converted into binary form. In binary, the number 4 is represented as 0100, and the number 5 is 0101. These binary digits are just representations of the numbers we use in the digital world. But the computer doesn't just understand the numbers themselves. It uses these ones and zeros to control the flow of electricity and process data. So, when these binary numbers are input into the CPU, they're not just sitting there. The binary digits are used as control signals, telling the computer exactly what to do. But here's a crucial question. How do these binary digits actually trigger the physical components like transistors inside the CPU? Well, that's where the power supply and voltage regulation come in. Let's start with the power supply unit, or PSU. The PSU is responsible for converting AC, alternating current, from the wall into DC, direct current, that the computer can use. This DC power is then distributed across the computer, including to the CPU, memory, and other components. Now, different components in the CPU, like the transistors, need very specific voltages to function correctly. That's where voltage regulator modules, or VRMs, come in. These tiny but essential circuits adjust the incoming DC voltage to ensure that each part of the CPU gets the right amount of power. Once the binary signals, like 0100 for 4 and 0101 for 5, reach the control unit, or CU, inside the CPU, something amazing happens. The CU decodes these signals and decides which operations need to be performed. It then sends control pulses to the relevant logic gates and transistors that perform these operations. Now, let's dive into how transistors work. Transistors are tiny switches made up of semiconductor materials like silicon. When a binary 1 is received, a high voltage is applied to the base of a transistor, turning it on. This allows electrical current to flow through the transistor. On the other hand, if the binary signal is 0, no voltage is applied, and the transistor stays off, blocking the flow of current.
First of all, what went through my mind is how stupid am I to actually...
But how does everything stay in sync? That's where the CPU clock comes in. The clock sends periodic electrical pulses called clock cycles to synchronize the timing of operations. This ensures that the transistors switch on and off in perfect harmony, maintaining the correct order for processing operations like 4 plus 5. So, to summarize, when you input binary data like 0100 and 0101, these values don't generate the power themselves. Instead, they serve as control signals. The actual power comes from the PSU, which sends electricity through the VRMs to the transistors in the CPU. The control unit decodes these binary signals and sends instructions to the transistors, while the CPU clock keeps everything in sync. The result? Your computer can perform calculations, like adding 4 and 5, in the blink of an eye. Thanks for watching. I hope you now have a better understanding of how your computer translates binary data into electrical signals and how it uses transistors to perform operations. Don't forget to like, share, and subscribe for more tech insights. See you in the next video.